Hey everybody, this is a quick video on using and setting up Newton's second law of motion to figure out force problems and free body diagram problems. So first of all, we know that Newton's second law says that the net force is equal to mass times acceleration. And all that means is that if we have a bigger force for a certain object, constant mass, we get a greater acceleration, whether it's slowing down, speeding up, or changing direction. Or if we have the same force, then if we have a smaller mass, we'll get a bigger acceleration. If we have a bigger mass, we'll get a smaller acceleration. Force causes changes in motion. Mass resists changes in motion. So Newton's second law we often write as the sum of forces, sigma F equals mass times acceleration. Just keep in mind that this letter is the Greek letter sigma. It's the Greek S, capital S, and it stands for the sum of. So the sum of forces equals ma. You might see that used later on in math to represent the sum of as well. So let's say we have our free body diagram for a problem like we do over to the right. To use Newton's second law, what we first have to do is choose a coordinate system, and that's easy. We just choose an x direction that makes sense, usually in the direction of motion, or maybe y is in the direction of motion. But the important thing is we choose the positive direction to be the direction of the acceleration. Then we set up an equation for Newton's second law in the x and the y direction. They're independent, so we need to do one direction for each because the motions are independent at least. Then we just plug in our variables and then maybe plug in our numbers as well to solve for our unknowns. So let's do an example here. A 10-kilogram box is pulled across a smooth surface by a rope with a constant tension of 60 newtons. As it is pulled onto a rough carpet, it begins to slow down at a rate of 0.20 meters per second. Find the weight of the box, the frictional force, and the normal force on the box. And let's use G equals 10 meters per second squared just as an approximation to make this easier. Okay, so let's start by just setting up Newton's second law so we get a feel for what that looks like. Actually, let's think about what's going on. We have gravity pulling down, normal force pushing up, canceling gravity. We're pulling our box to the right, which means our velocity is to the right. But the box starts to slow down, which means our acceleration is going to be to the left. So that means that our positive direction is going to be to the left. Since we have no motion up or down, it doesn't matter what our positive direction is up and down. Let's just set up Newton's second law in the x and y. Sigma Fx equals max. Positive direction is left, so in the x direction I just have the force of friction. And in the negative x direction I have force of tension. So I do minus force of tension because it's negative equals mass times acceleration in the x. That's my Newton's second law equation. I can also do it in the y. Sigma Fy equals mass times acceleration in the y. I can choose up or down to be positive because there's no acceleration, there's no motion in the y. So I'll just choose up to be positive. So normal force is positive, then I do minus force of gravity equals may. Well, but there's no motion in the y direction, so acceleration is 0. So normal minus gravity equals 0. And that's our basic setup with variables. Then we want to think about actually plugging in numbers. So what are we given here? We're given that the force of tension is 60 newtons. So I'm going to add that to my diagram, 60 newtons. Leave space. We're also given the mass, 10 kilograms. So since force of gravity is mg, the mass is 10 kilograms times 10 meters per second squared. That's 100 newtons. So let's look at the x direction and try to use what we know now to solve it. Our force of friction is still unknown, so we leave it as a variable. Minus our force of tension, 60 newtons, and we just put the magnitude in this equation. We already accounted for direction here. Equals mass, which is 10 kilograms, times acceleration, 0.20 meters per second squared. That simplifies to force of friction minus 60 newtons equals, well, 10 times 0.2 is just 2 newtons. Add 60 newtons to both sides, we get force of friction equals 62 newtons. We already solved for the force of gravity. Next up is the normal force. Well, normal force minus gravity is 0, so normal force has to be equal to the gravitational force. In this case. It's not always the case, but it's just because they cancel. If I plugged in my numbers, it would be normal force minus 100 newtons equals 0, or normal force equals 100 newtons. And keep in mind that this is kind of a formal way to deal with any type of problem. It becomes really, really important and useful as we get to harder problems. But easier problems like this you might be able to solve just by looking at them. For example, if I know that normal and gravity are the only y forces and there's no motion, I know that the normal force has to cancel gravity. So I'll put that as 100 newtons. If I could find the net force using mass times acceleration, 10 times 0.2, if I know the net force is 2 newtons to the left, then the force of friction has to be 2 newtons more than the force of tension. So it's 62 newtons. And Newton's second law basically sums that up in one equation. So in summary, set up Newton's second law in the x and y direction, plug in what you know, and solve. Keep in mind this is after you've already drawn your free body diagram. Hope that's helpful. Bye.